You got it figured out?
Yeah.
Okay, good. Good.
I didn't close the parentheses.
Exponential and logarithmic models. Your job today is to read a problem, pick out the information, and set up a model, an equation, that's going to work for anything. I need to know what kind of equation will give me the answer at any point in time. Now remember, some graphs are exponential, some graphs are logarithmic, and we're going to talk about models, equations, okay? Okay, so here's your first problem. This one you can actually handle on your own, so I'm just going to ask you to read it, set up some kind of equation, solve it. You can do it. You can do it. You're not reading it. Okay. Okay. Guys, did this mean anything to you? When money is compounded continuous, did that mean anything? Okay, good. Okay, you just need to know this. PERT is like this. Okay, and over here we put the letter A. What did P stand for? The initial amount you invested, right? What does A stand for? Final amount after how many years? Okay, well, here's the deal. A savings account has a current balance of $12,253. It has been earning 4% interest compounded continuously for the past, what? 8 years. How much was invested 8 years ago? Which one are you looking for? Yeah, you're looking for the initial amount. So you guys should have been thinking, I'm looking for P. P grew to what? Yeah, $12,253. This is the initial amount. We grew this far. Well, how long did that take me? That took me what?
8 years.
8 years. At what interest rate? 0.04. Is that what you did?
Yes.
Okay. Now, you're missing the P value. It's P times this number. Now remember, is that a number E or is that a variable?
It's 2 point whatever.
That's a number. So guys, you actually could compute this right now. What's E? Raise it to the 0.04 times 8.
8.326.
Well, you know what? I really don't care. I guess I'm just gonna write this. I'm gonna write this. Do you guys agree that this times this is 0.32? Okay. Here's why I said I don't care what it is, because I'm not going to write that big number down. I'm just going to do this. I'm going to solve for P by dividing by what? E to the power of 0.32. That's what I'm going to do. Okay, and this gives me the initial investment. How much money did, 8 years ago, how much money did I put in the bank? Say that again. $97.50. That's strange. Last hour I thought I got 98. Didn't I get 98?
I mean, if you round.
If you round, it's 98.
Oh.
Yeah, but I don't think she rounded.
It was 98, yeah.
It was 98 something, wasn't it? Did you divide by E to the 0.32? Okay, and maybe she didn't do that. Maybe that's what it was.
Oh, maybe they did the 1.32. 0.377.
Yeah, maybe,
That's what I got.
maybe they took E, raised it to this power, and then rounded this answer. Yeah, who knows what happened? But to be honest, guys, this is the right answer. If you divided by E to the 0.32, you got the right answer. Okay? All right. Are you okay with that? How many? Listen to the second part. How many more years will it take the original deposit to double in value? You did this on your worksheet. Should be easy. Go. Double that initial investment. This is the initial investment, right? If you double this, what do you get? 17 what? 795. Thank you. Okay. Okay, you ready? We're solving for your variable. Where's your variable? It's in the exponent spot. So this is what kind of equation? Exponential. We've said this. Isolate the base. Get the base by itself. So divide by 8,800, right? What would you get if you divided by 88.97 50 cents? 2. And then this would be e to the 0.04 t, right? Yes? Now what? Take the natural log of both sides, and when you take the natural log of both sides, you get natural log of 2 equals natural log of what? E to the 0.04 t. Yes or no?
Yes.
Raise your hand if you say no, it's okay. All right, ready? Base E here, base E here, they cross out. So really this is all it is, isn't it? ln of 2. Time. How much time does it take to double your money?
17 years.
Point what years?
3.
3 years?
But then it'd be 3 more years.
Gotta then take away the amount that was at the beginning.
Well, the beginning of the problem said how long will it take to double your investment,
How
right?
many more years?
Oh, how many more years?
From
Oh.
the original deposit.
From 17.3.
So you already know 8, so then you have to take away 8 and you get 9.
Original deposit, right? There's the original, right? Doubles in value. I read it as 8 years from now. 8 years from now, I have this much money. But if I start back at the original amount, back to the original of this number, to double that, I read it as,
Right, but
How
then it's
many
asking
more
how
years?
many more from
Yeah,
that
oh, I
date.
see what you're saying. So you're saying basically take my answer,
That's the total.
17.3,
That's how many years altogether. but
And then
you're
subtract
supposed
what?
to know after 8.
8. Oh. And you get what?
9.3
9.3
years.
more years to go. Okay. Good. That one you can handle because that one, that's just what you've been doing, right? Okay, here's a couple things I want to tell you. Today, you'll see when I go to the, well, maybe I will. I'll just go to the next slide. Today, you will be working with this kind of model. The exponential growth or decay model looks like this. This is just a general model. Y equals A times e to the bx on both of these. When is it going to be growth? When your b value is what? Greater than 0. So if you know you have a growth problem, your b value today, because this is your goal, guys, get the b value. Go get the coefficient in front of x. And then if your b value is negative, then you have what? Decay. Growth happens when this is positive, And decay happens when this is negative. When I say this, I mean the B value. Okay. Right here, guys, I gave you a little blurb. A is what? The original amount or value of whatever we're talking about. B is called the what? Like, how fast is something really going to grow? You know, everything grows at different speeds, right? You get what I'm saying? Like, mosquito population grows at a different speed depending on the weather. If it's really, really hot, what happens? They grow fast. If it's kind of cold, they don't grow. I mean, their population doesn't grow much. So lots of things determine the growth factor. Today, you have to figure out what? The growth factor. And it's not going to be as easy as you think, but it's not that bad. Now, come over here, because I wrote this to you, and I thought this was a little better. Okay, see this? This is your job today. A is the what? Whatever we're talking about, that's the initial amount. B, that's the growth factor that we're going to find. What's X now? X takes the place of time. Time can be in years, months, days, hours, seconds. Okay? All right, what's Y? The current amount at what given time. They're going to give you a time, and this is kind of what you have to think. Oh, 10 months from now, here's the current amount. Like that. That's how you have to think. So this does a little better job than this little blurb right here, okay? All right. I did not give you much room to show work on this next problem. I'm sorry, but I need more room, so I'm going to get myself more room. You just have to crunch. Here we go. Read that problem and see what you think right now. See you tomorrow. 20 rabbits are delivered to your home. 16 months later, you have what?
32 rabbits.
32 rabbits. Find the growth factor B and write the model for this situation. Okay. So guys, the rabbits are growing in population. All right. How do we do it? First of all, we write this down. We write down the model. The model is y equals what? A times e to the bx. Okay? All right. Now start like this. Pick out the information they gave you and put it in maybe ordered pairs. Remember, X stands for what? Time. Y stands for what? Amount. Amount at a given time. Okay? So give me a couple ordered pairs, will you? 1632 says Zoe.
020.
Ooh, that was quick. That took us forever in period 5. 16 months later, you have 32 rabbits. Well, where'd you come up with a 0?
Because that's the first month.
Your initial start.
It's your starting point. No time has gone by. Today, you just got what? 20 rabbits delivered to your house. Okay, you have 20 on day 0 or month 0. Okay, all right. Find the growth factor, what? B, it's right here, guys. Find B and write the model. Well, what do we know? Do we know this? What was the initial amount? 20 rabbits. E is a number. Don't think of E as a variable. And then we don't know B. We don't know B. We have to figure out B. What about X? 16 months go by. How many rabbits? 32. You see what happened? 20 grew to what? 20 grew to 32 over 16 months. Okay, solve it for B. Ready, set, go. I'm isolating my base. I'm taking the natural log of both sides. crossing out my bases that are the same. So I get 16b equals what? Natural log of 1.6. Divide by what? 16. Answer for B. By the way, should B be positive or should B be negative?
Positive.
Why?
Because it's growth.
It's growth. You guys, you should know if B is positive or negative. Okay, so what is it? 029? Okay. You just found what? You found this right here. You found that number, and that's all they wanted you to find. They said, write the model for this situation. Okay, I'll do that. Okay, so the model is, here it goes, y equals a times e to the 0.029x. That's the what? That model. You guys, that's a graph. You could graph that, and you could see the picture, but we're not going to. Okay, ready? Assuming the growth doesn't change, the growth rate doesn't change, how many rabbits will there be after what? 3 years go by. Well, that's time. Where do I put 3? Oh, right here. Right there, right?
But it's years
Yeah,
now.
but since he used months for the original.
Yeah,
you
see,
have
the
to-
only thing is, when you did this problem, it was 16 months. You were putting in months. So you can't put in years. You got to put in what? 36, don't you? So it's going to be 0.029 times 36 months go by. How many rabbits did I start with? 20. And then, of course, over here is, this is the amount of rabbits after 36 months. Kind of waiting for you. 57, did you round?
57 and a half.
Okay, 57 rabbits? Okay,
It'd be
57.
57. It'd be 58 if you round. Because it's 57 and a half.
56.8.
I got 57.
Oh, hey, guess what? Period 5 decided this, not you. You don't get to decide because period 5 already decided. Period 5 said, let's go further. Let's get one more number. So we did what in period 5? We didn't do 0.029, we did point,
0294.
is that what it was?
It'd be that.
There's a 4?
I didn't round it all. I
Okay.
just-
So, oh, you didn't round it all?
Yeah.
Then yours is even more precise.
Yeah.
Okay, so here's the deal. They went farther, and I think they got 8. I think they got 8. And I said bare minimum, let's go 4. Bare minimum. Because sometimes the answer is 0.00001. It's that small. Anyways, they went farther, they got 58, and you did the exact number,
Yeah.
and you got
which
what?
is, if you don't round it, 57.58, so 58.
Okay, so it goes 58 anyway.
Yeah.
All right. Good? Ooh. New. Not double your money, but what? Half life. So things do decay, right?
Yes.
Things kind of go away, right? So things
Yes.
disappear over time, and they talk about half-life. So if something sat on the ground for a long time, it will disappear over time. Okay? It'll just decay away. All right. So half-life means this. If I tell you something disappears, half of it disappears in 200 years, that means if I start with 20 pounds of something, in 200 years it's what? 10. Okay, get it? Okay, so then I wrote a little note to you guys, and I forgot to talk about this already. Shoot. I forgot about when something doubles versus half-life. When something doubles, 5 goes to 10, 20 goes to what? 40. But I said in period 5, I said, well, what if I start with 1? 1 goes to what? 2. Do you realize when I divide by 20, what do I get? Divide 40 by 20. 2. Divide 10 by 5. Guess what? Do you have to put these big numbers in? No. Do you guys remember that problem we already did? It was $8,000 doubles to $17,000. Remember that first example? Could we have just said $1 doubles to 2? It would work every time. Just like half-life. Half-life means 10 goes to 5, 50 goes to 25, but couldn't I just do this? 1 goes to what? Can't I just use this number every time? Divide 25 by 50, what do you get? Half. You're going to get a half anyway. Now, if you guys want to put in all those big numbers, go ahead. Put them in. You're still going to get that half anyways. Okay. So what does half-life mean? The initial amount of time, the amount of time necessary for a substance to be reduced to 1/2 its original amount. So guys, if you wait so many years, it's half gone. So that means 50% is gone and 50% is still what? Still there. Okay? All right. Here's an example. If a certain substance has a half-life of 40 years, what is the equation that models this decay? I'll give you 30 seconds to go on this. I know you can do it. Give me the formula that will work on this problem every time. Seconds is up. I'm sorry. What do you know? Half a life. This is half-life. So what did I start with? You can make any number up you want, guys. 1. Pick the easiest number there is. You started with 1 pound of something, and 1 pound turned into what? Half a pound, right? Times e to the what? Bx. Well, how many years does it take to get from 1 to go to half? 40 years. That was the problem. That's the only way you're going to find B. Now, by the way, right now, guys, haven't we isolated the base already? Isn't the base all by itself? It's right here. How do you solve this? Take the natural log of e to the 40b. Set it equal to the natural log of what? 0.5, half. Cross out the e's. E and e go away. 40b equals natural log of what? 0.5. Divide by what? 40. Here it comes. B, what's right here? B is roughly
Negative 0.0173.
okay. Good. Guess what? Your job is to write a model for this. So the model would be, start with any number A, e to the what? Negative 0.0173x. Good. And this would be your model, right here. Yeah? If I want to know how much is left after 40 years, I put it right there. The starting value, you could make that up. Or maybe in the problem they actually give it to you, but they did not give it to us here. Okay, let's continue. What percent of the substance will remain after 30 years go by? Okay, hey guys, what percent remains? Let's say I wait 40 years. What percent is still there? Half. 50% is still there. Is your answer going to be bigger than 50% or smaller? You're only waiting 30 years, not waiting 40. So what's left? More than 50% or less than 50%? It's more. It's going to be more. Okay, so you take your 30 years and you put it where? In for x. What was your multiplier? Right here, I guess. 7.3, right? And then you got to decide, what do you want to start with? How much do you want to start with? How much? You want to, how come you picked 100?
So that you can tell what percentage.
Then you can tell what percentage. Okay. You know what I picked, Tommy? I picked 1, but I get what you're doing, Tommy. I like what Tommy's doing. He says, I'll start with 100, and then whatever is left, I kind of know the percentage. Okay, so what's left? I don't know. I can't do that. 100 times e to the whatever this is. 50 what? $59 point what? 512. Okay, you started with 100, and over 30 years you're down to 59. Let's say 100 pounds. You're down to 59.512. What percent is that? Isn't that going to be exactly 59 point? Well, I won't say exactly. I'll just say this. About 59.5 is left percent. Do you see what Tommy did? He started with 100 because he knew if he got this number, he knew 59 out of 100. Oh, that's 59%. I didn't do that. I didn't do it that way. I just started with 1. Guess what my answer was? My answer was this. Yeah, this was my answer, and then what did I do? I just multiplied by 100, I just moved it over, and then I said, this is what's left. Okay, so I did it different than Tommy. I like Tommy's way better. Okay? You okay? This is all the further we got last period. Do you want to try one more? Because there's one more slide.
Yeah.
Do it.
Do it?
Do it.
I just don't know. I'll give you your calendar, and I don't know how much you guys can get done. I think there's 9 problems for you to do, and I don't know. Maybe we can get it done. I don't know. Go. Try and read it. Read it and do it. Here's your calendar. I'm just gonna walk around quick. So you've got to know your B value in these problems. You have to. And the only way to get your B value, guys, is to use, this is half-life, right? And because it's half-life, you could do this, right? 1 goes to what? Half. Over time, how much time went by? Yeah. So basically, you had to do that. You had to do that. I'm sorry, the clock tells me I have to hustle. Okay. Did anybody do that? Yes, and what'd you get?
Negative 4.334 times.
Oh,
10 to the
negative what?
4th. Negative 4.334 times 10 to the negative 4th.
Oh, so back it up. Okay, I gotta back it up. So it's negative 0.0004, right?
Yeah, and
Yeah.
then 334.
334?
Yeah.
Okay, I'll just put a 3 here. So there's your B value. You get it? I'm sorry, guys, I don't have time to do it and show my work, but that's it. So that would mean the formula would be y equals what you start with times what? E to the negative 0.000 4, 3 times x. Okay, and what we're trying to find out in this problem is what?
Starting point.
The starting point. So which letter?
A.
This is your job, find A. Well, guess what? You have this number here. Where's that go? In X. Where's this go? In Y. I knew that was going to happen. I don't know the answer. Or maybe you guys do. You guys know the answer?
I have the answer.
I want to say it's 17 point something.
It's 18.
Hey, did you guys get calendars? Hey, did I give it to you? Okay, good. Good. Is it 18.5?
I got 18.5, yeah.
Okay, guys, in case you want it, we'll talk tomorrow, I promise. Okay? That was the original starting point, 18.5.